Greetings from K.S.Rangasamy College of Technology. This is S. Muthukumar, Associate Professor from Department of Mathematics. In this video, I am going to explain about chi-square test. Chi-square test is used to test the difference between observed frequency and expected frequency. It was introduced by Carl Pearson in the year 1900. It is one of the non-parametric hypothesis test. So it is classified into two types. There is one is goodness of fit and another one is independence of attribute. The first one is goodness of fit. Goodness of fit is the test to test the significance of discrepancy between experimental values and the theoretical values by some theory or hypothesis. Here the experimental value, that means observed value, is denoted by O and the expected value is denoted by E. The test statistic formula for chi-square test is sum of I equal to 1 to n OI minus EI whole square divided by EI. That means sum of difference of square divided by expected values. So for applying chi-square test, the degrees of freedom is n minus 1. Before applying this chi-square test, we have to follow some conditions. That means conditions for applying chi-square test. The first one is the sample observation should be independent. That means there is no relationship between the observed values. The second one is cell frequencies should be linear. And the next one is the total frequency should be reasonably large. That means total number of frequencies should be greater than 50. And the next one, this is one of the important one. So all the theoretical cell frequencies should not be less than 5. If any values is less than 5 means we have to add it into the previous or next one to make it as greater than 5. Okay. This is the problem based on goodness of fit. Now go through the statement. The following table gives the number of aircraft accidents that occurred during the various days of the week. Now test whether the accidents are uniformly distributed over the week. That is, the number of accidents in a week from Monday to Saturday at a particular place is given. Now the question is, we have to check whether the accidents are equally distributed for all the days or not. So in this case, we can apply the goodness of fit test. For that, first we have to set up the null hypothesis. Null hypothesis means there is no significant difference between the days. That means the accidents are distributed uniformly over the week. Then assume the level of significance. In this case, I am assuming alpha is, that means level of significance is 5%. Now the test statistics is chi-square equal to sum of I equal to 1 to n OI minus EI whole square divided by E. So O is the observed value, that is given values. That is for given values Monday 18, Tuesday 18, Wednesday 12, Thursday 11, Friday 15 and the Saturday 14. Based on the given statement, given problem, we have to find out the expected frequencies. In this given problem, the expectation is the accidents are uniformly distributed. So we have to consider all the days. The number of accidents for all the days is equal. That means take the average of these 6 values. So add these 6 values and divide by 6. So the expected frequency, that means E, is 14, which is divided for all the 6 days. Now apply this test. Chi-square equal to, so first value 14 minus 14 divided by its corresponding expectation 14 plus 18 minus 14 whole square divided by 14 and so on, which gives the value of chi square. That means chi square equal to 2.143. Next, find out the degrees of freedom. Here the number of individual terms is 6, n equal to 6. For goodness of it, degrees of freedom equal to n minus 1, which is equal to 5. Next, take the Dabler values. For this degrees of freedom at 5% level. So the Dabler value of chi square is 11.07. Now check the calculated value. That means chi square value 2.143 and the Dabler value 11.07. Here the calculated value is less than the 11.07. So we can accept the null hypothesis H0. So accept it. That means we can conclude that the accidents are uniformly distributed over the week. Okay. The next problem. Go through the statement. The theory predicts the proportion of beans in 4 groups A, B, C and D should be 9:3:3:1. In an experiment with the 1600 beans, the number in the 4 groups are 882, 313, 287 and 118. Does the experimental results support the theory? So this problem is based on 1600 beans. These beans should be categorized into 4 types A, B, C, D. Here the categorization for the observed frequency is 882, 330, 287 and 118. Same time the expected frequencies is in the ratio of 9:3:3:1. Okay, so in this case we have to divide these 1600 beans into this ratio form 9:3:3:1 for calculating the theoretical frequencies. That means expected frequencies. For the first category, the expected frequency is 900. That means add all these ratio values 9:3:3:1. That means 9 plus 2, 9 plus 3 plus 3 plus 1, which is equal to 16. For the first category, the ratio is 9. So 9 by 16 into 1600, which is equal to 900. So the expected frequency for the category A is 900. Similarly, we can calculate the expected frequency for the rest of the categories B, C and D. Its respective values are 300, 300 and 100. So the given values are observed frequencies and the calculated values are expected frequency, which is based on the given statement 9:3:3:1. Now set up the null hypothesis H0. Here the H0 is the experimental results support the theory. Again I am using the same level of significance 5%. So here the values of O and E, that is observed frequency and expected frequencies, are given. Then apply the chi square test. The test statistic formula is given here. Use the respective values in the formula. The first case 882 minus 900 whole square divided by its expected frequency 9. Divide it. Similarly for the remaining terms also. So the chi square value is 4.726. Next, degrees of freedom. Here there are 4 values. So in this case, degrees of freedom equal to n minus 1. That means 4 minus 1 equal to 3. Now take the Dabler values. So the Dabler value of chi square at 5% for 3 degrees of freedom is 7.815, which is greater than the chi square. That means chi square value less than the Dabler value. So in this case, we can assert the null hypothesis at 5% level of significance. That means we can conclude that there is a very good relationship between theory and experiment. Thank you.